Now I'm going to do number 9 from page 291. Number 9, here's the question. Okay. Number 9 is, in still water, Maria can paddle at a rate of 7 kilometers per hour. The current in which she paddles has a speed of 4 kilometers per hour. A, at what velocity does she travel downstream? B, use vectors. Draw a diagram that illustrates her velocity going downstream. And C, if Maria changes her direction and heads upstream instead, what is her speed? Using vectors, draw a diagram that illustrates her velocity going upstream. Okay? So here we go. We got the two vectors, 7 kilometers an hour downstream paddling, and 4 kilometers an hour with the is the current. When you add the two together, you get this long vector going that direction. Okay? And the resultant is 11 kilometers an hour downstream. If you just said 11 kilometers an hour, that's not the velocity, which is what's being asked for in A. So you ask for the velocity. Velocity is 11 kilometers an hour downstream. Downstream gives you the direction. Okay? For part C, what if she was paddling against the current? So she was paddling upstream. Well, we could call downstream a positive direction, upstream a negative direction, and we could have a diagram that looks like this. So 4 kilometers an hour forward, negative 7 kilometers an hour backwards. And the resultant is the difference of those two, which is this, negative 3 kilometers per hour, or upstream 3 kilometers per hour. Now in this question, though, it asks for the speed. The speed is just 3 kilometers an hour. It's the magnitude of the velocity. So the speed is 3 kilometers per hour. That's number 9. We're now going to take a look at number 11 as well. So number 11 on page 292. Okay. So number 11. A small airplane is flying due north at 150 kilometers per hour when it encounters a wind of 80 kilometers per hour from the east. What is the resultant ground velocity of the airplane? So basically, what will happen to the airplane? Where will it actually head? If you're on the ground observing it, it's going to be, instead of flying like this, it's kind of going to look like it's going from its side and going like that because the wind is blowing it. Okay? So let's do this question. We'll draw it all out.
Could Claudia Laguerre please come to guidance? Claudia Laguerre to guidance. Thank you.
Okay, so number 11. Here we go. So number 11. Here's a diagram that we've got. Okay, so north, west, east, south. 80 kilometers an hour is the wind going west. Okay. It said in the question that it was coming from the east. So if it's coming from the east, it must be heading to the west. So you got to watch that wording. So 80 kilometers an hour, 150 kilometers an hour is the speed without wind. And here is the resultant of that. This is the path that it'll appear to be taking. And this is the angle that it'll go from north. Okay? It's just a simple Pythagorean theorem question, but you have to get your notation right. So you have to write in the vector magnitude squared equals 150 squared plus 80 squared, and then the resultant is 170 kilometers per hour. So that's the magnitude of the resultant. Then we want the angle. So we're going to look at tan of theta because we want to use the given data. What if we made a mistake with the 170? If you use sine or cos, you would have to use 170. But tan of theta is opposite over adjacent. That uses the given data. Okay? So 80 over 150, simple tan inverse on your calculator gets you 21.8 degrees approximately. And Here's your final answer on the right. Therefore, the resultant ground velocity is 170 kilometers per hour north, 28.1 degrees west. So from the north position, it's 21.8 degrees, or 28.1 degrees, sorry, from north heading towards the west. The other way of writing that is 28.1 degrees west of north. Okay? They mean the same thing.